All right. Problem number 4. We have a picture here, and it tells us that segment AB is congruent to segment CD. So AB is congruent to CD. Tells me that AB is 5x plus 8. Tells me that CD is 4x plus 10. And then it says that BC is 25. Find the length of AD. So we need to be finding from here all the way over to here. Well, if I knew how big each of these little segments was, AB, BC, and CD, I could just add those 3 together. AB plus BC plus CD equals AD. I know what I can put in here for BC. That's 25. But I don't know what to put in for AB and for CD. But what do I know about AB and CD? What? They're congruent. And what can we do with things that are congruent? Set them equal to each other. So I can take 5x plus 8 and set that equal to 4x plus 10. We're going to solve this for x. So the first thing I'm going to do is get my x's to the same side. So I'm going to minus 4x from both sides. 5x minus 4x gives me 1x. So 1x plus 8 equals 10. And then I'm going to subtract 8 from both sides. So I find out that x equals 2. How can I use that now? Let's see. Plug it in. We're going to substitute in. Yes. So for segment AB, that's 5x plus 8. So I have 5 times 2 plus 8. What is 5 times 2? 10 plus 8? 18. So AB is 18. So I'm going to put 18 in the place of AB. CD is 4x plus 10. We know that x is 2, so 4 times 2 plus 10. You said how much? 18. And does that make sense with what we knew from the beginning? Yes, we were told that those 2 segments were congruent. So we should know that that means they are the same size. So now I'm going to add 18, 25, and 18 together. Which gives us what? 61. So that is the final answer for this question. Lyndon. Your phone has to go up here, though. Right, number 5. You are given 2 points, T and N. T is negative 5, 3, and N is 6, 8. Part A says to graph and label segment TN on the graph to the right. So we're going to graph these 2 points, negative 5, 3. Right here is point T. And 6, 8 right here. That's my point N. And then we're going to draw in the segment. T and N are my endpoints. We do not go beyond the endpoints. If you take that line segment past the endpoint, it would be considered incorrect. So make sure that you stop at T and that you stop at N. What does this mean in part B? It says find Tn, but there's nothing over the top of it. What does it mean when I've got two letters like this and nothing over the top of it? The distance, yes. So find the length or the distance of Tn. So we're going to need to use the distance formula. If you don't have this on your cheat sheet yet, I would absolutely get it on there. Distance is equal to, and then we need a big square root sign. x2 minus x1 squared plus y2 minus y1 squared. And all of that should be underneath the square root symbol. So that means looking at my points, I need an x1, y1. I need an x2, y2. So I'm going to let t be my x1, y1. And I'm going to let n be my x2, y2. Would it matter if I switch that around the other way? No. Either one of these points can be the x1, y1, x2, y2. What you can't have, though, is a single ordered pair with two x's or a single ordered pair with two y's. Every ordered pair has to have an x and a y with it. So one of those is the x, the other one is the y. So then I'm going to take that and we're going to substitute in. We are finding the distance or the length of Tn. So I'm going to have that take the place of d. Big square root sign, parentheses, x2, that's 6, minus x1. Well, x1 is a negative 5, so that's going to be negative 5 there. Close my parentheses and square it. Plus, parentheses, y2, which is 8, minus y1, which is 3. Close the parentheses and square it. What happens right here? They add. When you subtract a negative, it turns into a positive. So I really have 6 plus 5. What is 6 plus 5? 11. So I have 11 squared plus, what is 8 minus 3? 5. So 11 squared plus 5 squared. What is 11 squared? 121. 5 squared. That's not an acceptable use of time right now. And then we add those two together. What is 121 plus 25? Close. 146. 20 plus 20 gives me 40. And now I want to take that and change it into its decimal form. Yes. We get that Tn is about, you said 12.083. If you don't know how to put that into the calculator, to get the square root symbol, you start with the green second button, and then you hit the x squared key. That's how you get the square root. And then you're going to put in 146, and if you hit enter then, it'll give you the exact same thing back. It'll just say square root of 146. To change it into the decimal then, after you hit enter, you hit the button right above enter, and that's what will change it into its decimal form. Technically speaking, I would accept either one of these as correct. You can give me the exact form or the decimal form. Part C says to find the midpoint for Tn. The formula that we use for the midpoint. The midpoint of a line segment is equal to, yep, sorry, my pen just stopped working all of a sudden. x1 plus x2, we add the x's, and then we cut it in half. We're finding the halfway point between the x's. And then we do the same thing with the y's. We add y1 and y2. We take that and cut it in half. That finds the halfway point between the y's. We are going to label this as point M. So I have M equals, we add those x's together, so -5 plus 6, and we cut that in half. And then we do the same thing with the y's. y1 is 3 plus y2, which is 8, and we cut that in half. What is -5 plus 6? -5 plus 6. 1. So I have 1 over 2, or 1/2. What is 3 plus 8? 11. So I have 11 over 2. So 1/2 and 11 over 2, or I can change that into its decimal form. That might make it easier for me to find on the graph. 1/2 would be what in decimal form? 0.5, yes. So 0.5 for the x part of the midpoint. What is 11 divided by 2? 5.5. So I would accept either one of these as correct. Then I need to go and graph it. I'm not going all the way over to the 1. I'm only going halfway over, so the x is here. And then I go up to 5.5 right here. That is my midpoint M. We have to put it on the graph, and we have to label it as M. So that's problems 4 and 5. Then we can go down and look at problem number 6. We don't know that. We don't know that. It doesn't tell us that, and we can't make that assumption based on the way it looks. But what I could say is that if I take this segment and I put it together with this segment, that gives us AC. So I could say that AB plus BC is equal to AC. Bless you. Can you see another statement similar to that that I could make? We don't know that. Remember, we're trying to write this about the segment addition postulate. And we can only use the picture in front of us. They are not marked as congruent. They didn't tell us that they were congruent. We cannot say that they are congruent. You cannot just go based on what the picture looks like. BC plus CD equals what? It does not equal AD. Equals BD, yes. What about if I wanted something equal to all of AD? How many pieces do I have to add together to get all of AD? AB plus BC plus CD equals AD. We could absolutely do it like that. What would I have if I did AD minus AB? So AD would be this whole thing minus this. What would be left? DB or BD, yes. What about if I had the whole thing, AD, and I took away CD? AD minus CD, you said would be what? AC. Could I, if I wanted to, add AC and CD together? Could I add AC and CD? It would give me AD. I could keep going. It only had 6 slots, but there are a couple more that I could do on here. Segment addition postulate means that I have to take 2 segments that are side by side, I add them together to get the big segment. Or I take a big segment that's cut into pieces, I take the big segment minus one of the little segments, and it gives me the remainder left over. Whatever I didn't subtract would be what I have left. That finishes out that page. What else would you guys like to see? 10, 11, and 16? Absolutely, we can. All right, so starting with number 10, it says the measurement of angle 2 is 4x plus 10. So I'm going to add that to my picture. Right here. 4x plus 10. Measurement of angle 1 is 2y plus 10. Here's angle 1. 2y plus 10. And the measurement of angle 4 is 10x minus 20. What do we know about angle 2 and angle 4? They're the same measurement. They're congruent. And how do we know that? What's the name for this special angle pair here? Vertical angles, yes. And vertical angles are congruent. So I can say angle 2 is congruent to angle 4, which means the measurement of angle 2 is equal to the measurement of angle 4. Well, the measurement of angle 2 is 4x plus 10. The measurement of angle 4 is 10x minus 20. And now we're going to solve this for x. So the first thing I would do here is get my x's to the same side. So I'm going to subtract 4x from both sides. So I have 10 equals 6x minus 20. Then I'm going to move my constant. I'm going to add 20 to both sides. What is 10 plus 20? 30. So 30 equals 6x. Then we divide both sides by 6. Does 6 go evenly into 30? Yes, 5 times. 5 equals x. That is the first thing that they asked me to do here. Is angle 1 congruent to those two angles? Is angle 1 congruent to angles 2 and 4? No. But I still have to come up with some kind of a relationship here. Angle 1 and angle 3 are congruent. What do we call angles 1 and 2 or 1 and 4, where they're side by side like that? That's a linear pair. And what do we know about linear pair angles? Are they congruent? No, they are. They add together to 180. Yes, they are supplementary. So because they are supplementary, that means 2y plus 10 plus 4x plus 10 equals 180. Do we know how big x is? X is 5, so we can substitute that in right here. So 2y plus 10 plus 4 times 5 plus 10 equals 180. 4 times 5 is what? So 2y plus 10 plus 20 plus 10 equals 180. We're going to combine all of our constants together, all of our things that don't have a variable. 10 plus 20 plus 10 gives us 40. So 2y plus 40 equals 180. Then we're going to subtract 40 from both sides. What is 180 minus 40? 140. And then we divide both sides by 2. What is 140 divided by 2? 70. So x is 5 and y is 70. That is problem number 10. Problem number 11. To do problem number 11, there are 3 formulas that have to get used here. And if you don't have these 3 formulas written down somewhere on your cheat sheet, I would highly recommend getting them written down. Let me give just another moment. All right. Kirby, do you need to snap a picture? Okay. We need the formula for circumference. The formula for circumference is C equals 2 pi r. We also need the formula for area. Area of a circle is pi r squared. You need both of those formulas. What does the r mean in both of these places? Not radical. Radius. That's what the r means in each of these formulas, is the radius. The radius of a circle goes from the center to the edge. When I look at the picture they gave us, we have a point that's at the center. We have a point that's at the edge. So if I draw a straight line in between those two, that distance right there is the radius. So I need to know how big it is. I need to know what that distance is. So I need the distance formula also. Distance equals big square root sign, x2 minus x1, close it and square it, plus y2 minus y1, close it and square it. So those are the 3 formulas that you need for this problem. If you don't have all 3 of those formulas down on your cheat sheet, I would absolutely put them there. So one of our points has to be 0.1. The other point has to be 0.2. I'm going to call B my x1, y1, just because it was the first point that I saw as I was looking at my paper. And so that means I would call A my x2, y2. You could flip it around the other way and you're going to get the same final answer. So we are finding the distance from A to B. So I'm going to replace D with the length from A to B. Big square root sign here. And then we do x2, which is 5, minus x1, which is 2. So 5 minus 2, close my parentheses and square it, plus parentheses y2, which is 3, minus y1, which is 1. Close the parentheses and square it. What is 5 minus 2? 5 minus 2. 3. So I have 3 squared plus 3 minus 1, 2 squared. What is 3 squared? 2 squared. So I have 9 plus 4 underneath my radical. What is 9 plus 4? 13. So I have the square root of 13. We're going to take that and change it into its decimal form. So you want to grab your calculator. You push the second button right here, and then x squared. That's how you make the square root symbol show up on the screen. And then 13, when you hit enter, it's just going to tell you square root of 13. Then you hit the button right above enter, and you should get 3.60555 something. So I'm going to round this to 3.606. This is the radius. So that's what we're going to put into both of those other formulas in the place of r. So I have c equals 2 pi times 3.606. You are going to use the pi button on the calculator, which is right here. We're not replacing that with 3.17. So 2 times pi times 3.606. Oops. You get about 22.657. And then we substitute in for r into the area formula. So I have pi times 3.606, and then we square just the 3.606. So I start with the pi button, and then parentheses, 3.606, close my parentheses, and I hit the x squared key, and I get about 40.851 when I round that out to 3 decimal places. Not necessarily. Angle CDA is this angle down here. That is all I really have time to take questions over today. I'll take questions again tomorrow over anything that you guys want to see from the test review. I do want to leave a couple minutes right now so I can pass back your tests from last week so you guys can see how you did on those. Don't forget, you're going to turn in the packet when you come in to take the exam on Thursday. You're going to turn in your green paper tomorrow.